Welcome to EDU World Space.
So this question is about the Bohr model of an atom, of a hydrogen atom. And we first want to get an expression for the electron speed. And so we want to set the electric force equal to the mass times the acceleration. And then, so force for circular motion is mv squared over r. And then the electric force has a magnitude of QE, and therefore V is equal to QE times R divided by M square rooted. Just doing the algebra for that. And then we want to get the kinetic energy. Next, kinetic energy is equal to 1/2 mv squared. So we want to do 1/2 m times the squared, which is just QER over m. The m's cancel, so it's just 1/2 QE times r. Okay. I'm just kind of curious if these are the terms that the question wants it in terms of the electric field. Should we use, I guess we can always plug in for the electric field of a proton. So I guess we can, let me modify these answers. So we know E is equal to KQ, and then these are the same Q, so I'll go ahead and use that. And they have the charge of an electron and the charge of a proton have the same magnitude is what I meant, over R squared. Therefore, if I plug that into here, then I get the square root of K Q squared, and then we're dividing by R squared, multiplying by R, so we'll end up with a factor of R down here, and then the Q squared, the R canceled, so yeah, so that's what that looks like. And then simplifying this one, we can do 1/2 Q, and then plugging in for E here again, should probably use a different color. You get 1/2 Q squared K divided by R. The factor of R here multiplies with this R squared factor to give you this. Great, and we want to show that it's just half of the electric potential energy. Oh, that's kind of nice, because then the electric potential energy between the two, so U is QV, V for a point charge is KQ over R, so U is going to be KQ squared divided by R, and indeed, this is half of that as required. So next, we want to get the total energy. I knew they were going to ask me to use numbers. And then we want the kinetic plus the potential, and we want to evaluate it using R is that. And I'm going to pause for while I do the calculation, although I guess I will quickly write down the total energy. So C E total is going to be kinetic energy plus potential, and then so that's going to be 3/2 KQ over KQ squared over R, and that's just using the just expressions for kinetic energy and potential energy. So, okay, now I'm going to actually pause it and do the calculation. Okay, so I plugged that into a calculator and I got 6.53 times 10 to the minus 18. Joules, and then dividing it by, to convert to EV, I need to divide it by 1.6 times 10 to the minus 19. And then when I did that, I got 40.8 EV. And then the 6 looks funny, so I'll go ahead and fix that. Just going to double check my calculation. 3 halves, K, Q. Yep, looks good to me.